Let's learn how to solve radical equations. Many times, equations contain either radical expressions or radical exponents. Examples include one strategy for solving an equation containing a square root is to isolate the square root if necessary, and then square each side of the equation. This technique is an example of the power rule for solving equations. I will let you read the power rule for solving equations. Note, after applying the power rule, the new equation can have solutions that do not satisfy the given equation, which are sometimes called extraneous solutions. We must always check our answers in the given equation after applying the power rule. Here are the steps solving a radical equation. Step 1, isolate the radical term on one side of the equation. Step 2, apply the power rule for raising each side of the equation to the power equal to the index of the isolated radical term. Step 3, solve the equation. Step 4, check your answers by substituting each result in the given equation. All right, let's get started. Example number 1, we can see that the square root is already isolated. So the index is a 2. So we are going to square both sides. When you square a square root, you get the radicand. And 7 squared is 49. We will subtract 5 from both sides. Divide both sides by 4. Y is equal to 11. And then we want to check to make sure our answer of y equals 11 is correct. So our check. Four times 11 is 44. 44 plus 5 is 49. And the square root of 49 is equal to 7. So 7 equals to 7. So we know our answer is correct. Number 2, the square root is not isolated. So step 1 is to isolate the square root by adding 2 to both sides. Now that the square root is isolated, we will square both sides. When you square a square root, you get the radicand. And 3 squared is 9. Subtract 2 from both sides. X is equal to 7. Let's check to make sure x equals 7 is a solution. And sure enough, 1 is equal to 1, so we know our solution of x equals 7 is correct. Example 3, first need to isolate the radical by subtracting 12 from both sides. Next, we need to divide both sides by 3. Now we'll square both sides. and add 12 to both sides. And x is equal to 37. I will leave the check up to you. Example 4, isolate the square root by subtracting 8 from both sides. When is the square root going to equal a negative 5? Never. There is no solution. A square root is not going to equal negative 5. Therefore, we have no solution. Example number 5, now we have a cubed root. The cubed root is isolated, so let's cube both sides. Add 9 to both sides. And divide both sides by 2. Again, I'm going to leave the check up to you. Example 6, we need to isolate the radical by first dividing both sides by 5. Then we'll need to take each to the 4th power. And add 4 to both sides. Example 7, we have a square root on both sides, so we can square both sides. Or we can also think logically that in order for 2 square roots to be equal, the radicands have to be equal. And subtract 4y from each side. And subtract 4 from both sides. Y is equal to 3. I will leave the check up to you. And example 8, we will square both sides. We have a quadratic, we have an x squared, so we need to set it equal to 0. And we will factor. And we'll need to check our answers. First, let's check x is equal to negative 1. So is negative 1 going to equal the square root of 4 times negative 1 plus 5? And again, the square root is going to be a positive. So this is not going to be true. So x equals negative 1 is an extraneous solution. And let's check x equals 5. And 5 is equal to the square root of 25. So x is equal to 5 is a solution. The equation x to the n is equal to k, where n is a positive integer, can be solved by taking the nth root of each side of the equation. The following technique allows us to find all real solutions to this equation. Here are two examples. If we have x to the fifth is equal to 32, then we know that x is equal to the fifth root of 32, which is equal to 2. Anytime n is even, we need to make sure that we have plus or minus. So if x to the fourth is equal to 81, x is equal to plus or minus the fourth root of 81, which is equal to plus or minus 3. So the keynotes here is that when you take an even root of both sides, you must have plus or minus. Number 1, x squared is equal to 169. We can take the square root of both sides. And we have x is equal to plus or minus 13. We could also factor this. We could subtract 169 from both sides. We see that as a difference of perfect squares. And we could see x is equal to plus or minus 13 using this method. Example 2, we have the fourth root of 81. We're taking the fourth root of 81. We need plus or minus. So x is equal to plus or minus 3. Number 3, we have x cubed is equal to negative 27. So to undo a cube, we would take the cubed root. The cubed root of negative 27 is negative 3. Example 4, to undo a squared is we're going to take the square root. And we need plus or minus. The square root of a perfect square is the radicand. And we have two equations. We have x plus 3 is equal to 9. And x plus 3 is equal to negative 9. Subtract 3 from both sides. X equals 6 is one answer, and x equals negative 12 is the other answer. Example 5, we're going to take the cubed root of both sides. Add 2 to both sides, and x is equal to 7. Our last example, we're going to solve the equation for a. So let's square both sides. multiply both sides by pi d. And divide both sides by 11. And there you have it. Thanks for watching. See you next time.